Hello there. This is one of this was one of my personal projects that I worked with a friend of mine from high school, and we built this during one of the summers when I was in college. I want to say it was like after the pandemic, maybe. Yeah, I can't remember. Maybe around 2022, summer of 2022. I had to go take a good guess. So essentially, what we're trying to do right here, this is just a simulation set of it, just for the circuitry of the Arduino, all that stuff using Tinkercad. Essentially, what we were trying to do was build a robotic hand, but specifically a robotic hand that could be controlled using a real hand. Basically, mimicking your actual hand's movements with the robotic hand. And this was actually a very, again, a passion project with me and my friend. Um, and essentially, how this kind of works out, at least circuitry wise, is basically the input is basically these little things. These things are called flex sensors. So essentially, if anybody knows how a force sensor kind of works, a force sensor is very similar to a flex sensor, where a force sensor basically has like a bunch of like wire, just like in a sense like collided all together, like it's all like clumped up into like one little small little piece, and essentially the amount of like I guess force in a force sensor that you like apply to it, it sort of like gives out like a resistance of like yeah, like a resistance of like how much like voltage it kind of like gives out and gives in. So again, it's just like purely just wire in a sense. And basically that resistance number kind of gives out like, oh hey, like a little number, like, oh okay, you put that much force onto that thing, it's gonna display like, oh yeah, you gave out like 10 pounds of force or whatever the hell, you know. Same thing with this, but instead of force, it's how much you flex. So essentially, how much you flex, it kind of gives out that much resistance to that degree, and that could be just a readable number through the actual Arduino to be like, oh, okay, if it's at like, at this number particular, it's gonna basically control another mechanism. And when it's at that number, and the mechanism that we're controlling, the output of it is basically these servos right here. In total, it's five servos and five flex sensors. I wonder why it's five. It's five, just basically one for each finger in the hand, so five in total. Well, I guess a thumb's a finger. I don't know, or I don't know. You know what I mean? So essentially, this is basically, pretty much simply just controlled just by this. And I'm trying to remember what the resistor was. The resistor was just a 10 kilo ohm. So again, very simple setup, nothing too complicated, very quick. And essentially, what this kind of does is, at least like circuitry wise, is whenever this thing like flexes, like when you're trying to like flex like an actual finger, it's gonna go and try to mimic it using these servos. And why are the servos in here? So the servos here basically control, basically like a string that basically pulls on one of these fingers, and that basically sort of like mimics like how puppetry kind of works, at least for like a puppet hand, or to that degree. So essentially, if you pull on that string using a servo, it's gonna basically just compress itself. If you release that string, it basically extends itself. That's basically how that kind of works. I'm also gonna show. I'm gonna also like show some videos too of it actually working. We have like a very early Mark One version of it, just by using cardboard and the actual circuitry working. It's a little bit slower on the real life version. I think I have some ideas of why that could be, but this is basically the code right here. So maybe like an idea of how it could have actually been slow could have been just the serial prints itself. I think for the actual like main code, I might have like added like a lot of serial prints for each server position. So that kind of been an issue, or maybe the delay itself, even though the delay is only 100. And by the way, how the delay kind of works on Arduino is basically 1,000 of this number is basically just 1 second, so it's every like it counts basically a millisecond in a second, in a sense. Sorry, have a bit of a stutter. So essentially, to this degree, when I actually start the simulation, basically, you kind of see there's like a little number right here. Basically, just says that it's at 0 degrees. And essentially, when I try to like flex it, boom, boom, it controls the little servo right here. So I'm gonna go zoom out just a little bit. Ta-da! The servo kind of changes. So essentially, I programmed it in a sense where, um, basically when it does that spin, it basically just makes the, I guess, the string go the other way, which will kind of like just compresses the actual finger itself. And that's mostly how that kind of works. Yeah, that's mostly it, honestly. Let me see if I can try to do like a little peace sign or something. So yeah. And again, this was honestly just real fast, real quick. The code wasn't that bad. I remember I got the main gist of like how this all kind of worked was mostly from Adafruit, which basically, yeah, little peace sign, which basically supplied the actual flood sensors. They're actually not that bad to get. If I'm trying to remember, I think at the time it was like maybe like $15 to buy a piece, which honestly, I guess 15 times 5, that would be kind of expensive in that degree. And yeah, that's mostly it, at least simulation wise and coding wise. I'll definitely post up the simulation of this whole thing on either, just YouTube or the LinkedIn, yada yada yada. And I also post up some videos of like the actual thing working. We also had like another thing too on the side, where basically I don't have the code for it, but basically we basically had like a little IMU. And also, if anybody doesn't know what IMU is basically inertia mass inertia measurement unit, where basically it's sort of like detects your orientation in three-dimensional space. And I try to like implement it to basically just like, oh hey, if your like hand like moves at a certain way, we'll basically make the robotic hand move just by using another servo underneath of the actual like robotic hand. And sadly, that didn't work because at the time, this was before I actually figured out how to use IMUs using my capstone project, which I'll also post in the near future. Just still working on that. I'll probably just post it in videos, honestly, just piece by piece. And essentially, how that kind of worked was I didn't really know how to use it. I used like a very cheap one. I used one that costed like maybe less than like, actually no, I bought it in a pack of 5, which in total costed like $10 for everything. So that was maybe another reason why that didn't work out. So I kind of want to restart this project. This is actually a pretty cool project, and we only did it like in a cardboard case, quote unquote. I really wanted to do this like in the 3D printed mold, but we just had a lot of time constraints, and we were both busy. And but yeah, circuitry wise at least works to a degree. There's definitely still a lot of tweaks that we could have modified for sure. Because again, it was just slow. You're gonna see that in the video. But yeah, that's pretty much it. And I hope you guys enjoyed. And yeah, take care. Bye.